it says is just what adding and subtracting. You can always multiply. You can always multiply, but with adding and subtracting, you have to have exactly the same type of radical. So like they both have to be a square root, or they both have to be a cube root, and you also have to have exactly the same thing. So if you have the exact same thing underneath, then you can actually add or subtract. So what I got in example 1, this is just really quick, we'll go through this. So I have 7 times square root of xy, 3 times the square root of xy. Radicals are both square roots, they both have exactly the same thing. All you do, don't change any exponents, anything like that. We're just going to add the numbers in front. So I've got 10 square roots of xy, and that's literally all you have to do. Can I add together 2 cube roots of x, or sorry, subtract 2 cube roots of x minus 2 cube roots of 5? No. These are, like, this has an x, this has a 5, so these are not like radicals. So that is as simplified as that expression can be. I can't do anything, I can't break anything else down under either radical, so that's just going to be the answer to that question. We wouldn't do anything else. What if I had 8 cube roots of 9 minus the cube root of 9? 7. This always throws people off because there's no 1 in front of this, but this is 8 of these minus 1 of them, so there's 7 of them. And then again, you don't change, like it doesn't become 18 under the radical or anything like that. They stay exactly the same. So this one's almost the same question, but just 6 cube roots of 7 plus a cube root of 7. So I'd have 7 cube roots of 7. Notice I'm not changing what's under the radical at all. All right, I've got 7 fourth roots of 5 minus 2 fourth roots of 5. How many fourth roots of 5 do I have? 5. Done. That's it. Can I add the 2 together in the next question? No, 1's 7, 1's 17. You can't break either one of those down. So that's actually as simplified as possible already. I can't do anything else. What about 4 cube roots of 5 minus 10 roots of 5? Can't. This is super tricky. One of these is a cube root. This is a square root. They're not like radicals. You cannot do this question. It's already as simplified as it can be. And then the last one, I'm just going to grab this little yellow piece of paper that I had you guys. The numbers are up on the board too, but fourths you're probably not super familiar with, but both of these guys in this example are actually perfect fourth roots. So 16, if I take the fourth root of that, that actually just becomes 2. And 81, also on that list of perfect fourths, it's the third one down, so the fourth root of that is 3. If you already have something out in front of the radical and you pull something out, perfect fourth in this case, you multiply them together. So this is negative 30, and then plus 6 times 3 is 18. I don't have radicals anymore here at all. These are just plain numbers, and you can go ahead and put them together. This would be negative 12. Okay, is anybody having a question? Now, I know this is some of the stuff you guys did kind of on your own with the e-learning, but these, these questions do not look like they're like radicals, but they're also not simplified. I'm just going to do one of each. I'm going to do 1 square root, 1 cube root, and 1 fourth root just to save some time today. But if you can further break down the radical in the problem, you want to try to do that. So the first example here, I have 3 roots of 20, and I'm just going to do this real quick for time. So biggest perfect square that divides into 20 is 4. So I would rewrite that real quick. Has to be a product, has to be multiplication, is 4 times 5. And 45, anybody know biggest perfect square that goes into 45? 9. And then the last one, this one's tricky. Anybody know biggest perfect square that'll go into 80? Yes. 16 times 5. Okay, now if something's already out in front, you just, any perfect square that you can remove, you're just going to multiply it if something's already out in front. So square root of 4 is 2, square root of 9 is 3, square root of 16 is 4. I'm just removing any perfect squares to simplify those radicals. This first term, 3 times 2, we're going to have 6 roots of 5. Now I just have a subtraction sign in front of this next term, so we're just going to take that 3 that we can take from the square root of 9 and put that in front, so minus 3 roots of 5. The last term, 4 times 4, is going to give you 16 roots of 5. Now, when you do this, initially when I looked at that problem, they didn't look like radicals, but once I simplified each one of them, they are all 3 radical 5. Don't change anything under the radical, just the numbers in front get added or subtracted. So we'd have like 6 minus 3 would be 3, plus 16 would be 19 roots of 5. So initially when I looked at that problem, it didn't look like I could add them together, but once I broke them down to simplest radical form, they did end up being like radicals. Okay, now the question right next to this, I've got cube roots. So people usually are not super familiar with these as we start working on this unit. So cube root's going to be this third column here, and you're not doing anything to break down 2 under a cube root. What about 16? What's the biggest perfect cube that'd go into 16? I can take out a 2. How could I rewrite 16 as something times something? What'd you say? Yeah, exactly right. Okay, so here's my perfect cubes. You're going to remove a 2. This is 8 times 2. I know you guys are not familiar with these, but 8 is a perfect cube. That's what I'm trying to remove. Now, 54. So I'm looking at these. You don't want to use the 1 because that's not going to break anything down. So I'm looking at like 8, 27, 64. What of those numbers would divide into 54? The 27. Really, and if you're not sure, grab your calculator and check. Just like punch it in. Just take 54 divided by 8, doesn't go in. 54 divided by 27, you would get 27 times 2. We're doing a cube root here. That first term, we're not taking anything out, but that second term, the cube root of 8 is 2. It's 2 times 2 times 2 would give you 8, so the cube root of 8 is 2. You're trying to find a number multiplied by itself 3 times to give you that. The cube root of 27 is 3. So then, we're just going to keep that first term. -4 cube roots of 2. The second term, I've got a 7 out in front. When I take that cube root of 8 and get 2, that's going to turn that into a 14. And the last term, I'm going to pull out a 3 from the cube root of 27. So 9 times 3 is 27. And now these are each a cube root of 2. So we're just going to take the numbers in front, add them up. So I got -4 and 14 would be 10. Minus 27, so this should be -17 cube roots of 2. And then I'm done. Does anybody have any question? Okay, let me do this. I'm going to skip letter D, but let me do C. These are 4th roots. Okay, so if you're not super familiar, the 4th roots are like the 1, 16, 81, 256. Not too many numbers you would have to check, but here 32 is 16 times 2. And again, if you're not sure, just grab your calculator. Like the second term, I have the 4th root of 162. I would just check it real quick, like divide it by 16, see if it goes in. Divide it by 81, see what goes in. If you do 162, it should be 81 times 2. And then that last term, 3 4th roots of 512. 512 is 256 times 2. And you guys can have that little yellow paper while you're doing the tests and quizzes. So if you're not super familiar, and they're up on the board too, so just look at the list of numbers to help yourself. And now be careful, because sometimes these numbers will be on the list of perfect squares and perfect fourths, which is the case here. So if I'm doing a 4th root of 16, it's the second number in the list, so I'm going to take out a 2. Don't take out a 4. 81 is the 3rd number in the list of perfect 4th roots. So this is a 3, not a 9. So just be careful with that. 4th root of 256. 256, if you're looking at the list, it's the 4th number down. So you're going to take out a 4. Once you're there, then this is super similar to all the other questions we've just looked at, just working with a 4th root. So this would be 20 4th roots of 2 minus 18 4th roots of 2, and then plus 12 4th roots of 2. Take the numbers in front, add them up. So 20 minus 18 would be 2, and then add 12, so we should get 14 4th roots of 2, all simplified. The key is just breaking down the radicals and seeing where you can go from there. Is anybody having a question? I know I'm going kind of fast. Okay, I'm going to do 2 more with you on the back. These both involve variables, so you can still have like radicals if they have variables, which is what's going to go on here. I'm just going to do this real quick. The first question on the back, this is actually a situation where both of the numbers under these radicals are perfect squares. This is a square root, so 3 square roots of 225x. Anybody know square root of 225? My list only goes up to 12. Does anybody know what 225? 15, yes ma'am. All right, so that first term, 3 times 15, this is 45 square roots of x. All right, and then hopefully you guys know 144 will come out as a 12. That's a perfect square. 5 already in front. 5 times 12 is 60. Now again, these are like radicals, both of them times the square root of x, but you do not change, it doesn't become 2x, it doesn't become x squared. You literally just add the numbers in front. So 45 and 60 would be 105, and then you just copy that square root of x. That does not change when you're adding or subtracting. All right, and then I've got one more here really quick. So I'm pretty sure we did a 45 on the front. That's 9 times 5. Y squared is actually a perfect square, so I'm going to leave that alone. And 20, I'm pretty sure we did that on the front also, is 4 times 5. All right, so this is a square root, so square root of 9 is 3. What would you take out? Like I just left that as y squared. What's the square root of y squared? Y, perfect. Okay, now this guy, square root of 4 is 2, square root of y squared again is y. Anything we take out, if something's already in front, we just multiply it all together, and including the y. So 6 times 3 is 18 times y. This would be 18y roots of 5. All right. The other term, I've got 4 times 2, which is 8 times y. So 8y roots of 5. Now, both like radicals, both times the square root of 5. So again, you're not changing any exponents or anything like that. We're just adding together 18y and 8y. So that would just be 26y's, and then times the square root of 5. Don't change any exponents on any variables when you're adding or subtracting. Don't change what's under the radical after you've simplified it. Okay, I just went really fast through that. Does anybody have a question? Okay. Now, these problems down at the bottom, each one's just slightly different, but they involve maybe a step before. We're going to see if we can combine like radicals, and we're going to use multiplication here. Now, this first problem, a lot of people think this is a FOIL situation. It's not. This is just one term. It's got 2 parts to it, 3 roots of 7. This is just a little distributive property. So if I take 3 roots of 7 times 4, we're just going to multiply the numbers outside together. So it would be 12 roots of 7. That would just be that first term. Just numbers outside get multiplied together, numbers underneath get multiplied together. For the second term, I have 3 roots of 7 times another square root of 7. You can always multiply as long as they're both square roots. But what you do there, I'm just going to leave the 3 out in front. For the radicals, when you multiply, you actually do 7 times 7, so it'd be square root of 49. If you multiply a radical by itself, that should turn it into a perfect square. And so I can simplify this just a teeny bit. This term is really 3 times 7, because 7 is the square root of 49, and then that ends up being 21. You cannot go any farther than that, because 12 roots of 7 is a radical, and 21 is just a plain constant. So that's as far as I can go there. And that's just going to be my answer. Now, the next one here, I have negative square root of 8, and I'm going to multiply that. You can always multiply. They don't have to have the same thing to multiply. So as long as they're both square roots, we're good. So radical 8 times radical 2 turns into radical 16. I have a negative out in front of that because the radical 8 had a negative. Then, just distributive property here, negative times a negative in the middle here will become positive. And then 8 times 10 is 80. And I know this is one we broke down on the front. So square root of 16 is 4, has a little negative in front. Totally can do this. The negative is not under the radical. 80 is the same as 16 times 5, 16 being the biggest perfect square that goes in. So that would come out as a 4. And then don't actually add these together. So it'd be negative 4 plus 4 roots of 5. Can't go any farther than that, because one has a radical, one does not. So those are both distributive property. Does anybody have a question? Okay. Next problem I I've got 8 plus the square root of 11 and 1 minus the square root of 11. This works just like a little foil, or if you want to draw yourself a box. I just think of it as a double distributive property. I'm going to multiply 8 by both of those terms in the second set of parentheses, and then I do the same thing with the radical 11. So 8 times 1 is 8, minus 8 times that negative radical 11 is just going to be negative 8 roots of 11. And then I'm going to multiply square root of 11 by both of the terms. So square root of 11 times 1 would just be plus, and you can write the 1 or not, it's up to you, but plus 1 square root of 11. I will have some like terms I can combine in there. Now, the last term, positive square root of 11 times negative square root of 11. Positive times a negative makes a negative. And then 11 times 11 is going to make 121, which is a perfect square. Okay, now, in the middle here, you have negative 8 roots of 11 plus a square root of 11. So it'd be negative 7 square roots of 11, combined like radicals there. Now, the term on the end is a perfect square. So minus the square root of 121 would be minus 11. Now, you can simplify this guy a teeny bit further. You're going to take the 8 and the negative 11. Those are both plain numbers, so you can just add them together. So 8 minus 11 be negative 3, and then minus 7 square roots of 11. Can't go any farther than that. Anybody have any questions? Now, I have square root of 2 minus square root of 3, all of that squared. How would you go about doing that problem? Do what? He says 2 minus 3 just cancel out. That's what I would think initially. What's wrong with that? So that's what everybody tells me to do. What do you think? You don't want to distribute the exponent. What does it mean if I square something? You're multiplying it times itself. Okay, this screws everything up. Anytime if they're just multiplied together, right, then you can distribute the exponent. If you've got adding or subtracting in here, you got to make sure you write it out multiplied by itself. This is actually going to create a little foil again. And I'm sorry, but if you don't do that, you're going to completely miss out on the middle term, so you won't get the answer correct. Those radicals are going to get squared, and they are going to cancel out, but you are going to have a middle term. And then you would miss that if you just distributed the exponent. Anytime you got an exponent, adding or subtracting inside the parentheses, just write it out times itself. So now root 2 times root 2 is root 4, which will give you 2. But you'd miss out on this middle term. So square root of 2 times this negative square root of 3. 2 times 3 is going to give you 6. So I have minus the square root of 6. I'm going to turn around and get that again. These will not cancel each other out. So negative square root of 3, square root of 2, another negative square root of 6. Then negative times a negative, I'm going to get positive square root of 3, square root of 3, square root of 9. So this is 2. Now these ones in the middle don't cancel. You have negative 1 here, another negative 1. So you have negative 2 roots of 6, and then plus 3. The only thing I would tell you here, just be real careful because people will mess this up. So they'll see a subtraction sign here, but for the plain numbers, you have a 2 and a positive 3. So that actually simplifies to be 5 minus 2 roots of 6. So just make sure you use the operation symbol in front of the term you're going to combine. Okay, now I've got 2 more, and these will go really quick. This is just a little more complicated looking. So it's still kind of a foil. 2 times 1 is 2. Now, if I have 2 times this negative 5 roots of 6, I'm just going to do 2 times negative 5, so it'd be negative 10 roots of 6. Then I'm going to do 4 roots of 6 times both of these terms. So 4 roots of 6 times 1 would just be 4 roots of 6. Now for that last term, you're going to multiply the numbers on the outside. So 4 times negative 5 is negative 20. And then you can also multiply the radicals together there. Radical 6 times radical 6 would be radical 36, which is going to be a perfect square. In the middle here, you can combine like radicals. Negative 10 and 4 would give you negative 6 roots of 6. On the end there, you really have negative 20 times 6, because 36 is a perfect square. And so you don't have to write out all these steps if you guys understand this. I'm just going to try to show you where it comes from. Negative 20 times 6 is It's going to give you negative 120. And then you can actually combine some like terms here. I have a 2 and I have a negative 120. So I should get negative 118 minus 6 roots of 6. We're not factoring anything like that or anything, so just go ahead and leave it like that. And then the very last one, real quick, and this is going to actually lead into what we'll be working on in our next lesson. These are called conjugates. So that's when the numbers are exactly the same, but one's a plus and one's a minus. Does anybody remember from first semester what happens if you multiply conjugates together? The middle terms cancel out, for sure. So I'm just going to write it all out so you can see it, but if you guys remember that, you can just skip this if you want. Okay, so like root 5 times root 5 is root 25. Then you're going to get minus the square root of 10. But you're going to turn around and you're going to get plus the square root of 10. The one thing to remember on the end here, the positive times the negative, you'll always have one of each when you have conjugates because one has to be a plus and one has to be a minus. So on the end here, it should be minus 2 times 2 under a square root would be 4. These guys are gone. I end up with square root of 25, which is 5, minus square root of 4, which is 2. And then the answer ends up being just the number 3. All the radicals cancel out. We're going to use that in the next lesson when we work with some fractions here. So, does anybody have